Hi, you're welcome back to my YouTube channel. I'm Alex, and this is program mathematics. Okay, so if this is your first time of coming in contact with this YouTube channel, please subscribe to my YouTube channel, recommend the YouTube channel to your friends, your relatives, everyone around you, and also give me thumbs up on the videos. I like the videos, and please, your comment is very, very important to me. So in the last video, I explained the types of matrices, and I gave simple the first three types. I mentioned the square matrix, okay, the square matrix, where I told you that the square matrix is a matrix, okay, which has all the number of rows and columns being the same, okay, and we refer or denote the square matrix, let's say matrix A by n, n by n. So the n here means the number of rows and number of columns, so they are equal. So you can have a 2 by 2 matrix, it's a square matrix. A matrix having 3 rows, 3 columns, 3 by 3 matrix is also a square matrix, or 4 by 4 matrix, and so on. And then apart from that, we have what we call the identity matrix, and the identity matrix also is a square matrix, okay, in which all the elements along the principal diagonal, okay, they are ones, and every other element, okay, is 0. So we can have a 2 by 2 identity matrix, 1, 0, 0, 1, or if it is 3 by 3, you have 1, 0, 0, 0, 1, 0, 0, 0, 1. You can have 4 by 4 and so on. And of course, we also have a 0 matrix, which is also a square matrix, okay? But in this case, all the elements are zeros, and you know that by this O, which is n by n. Okay, so today we want to look at transpose of a matrix. Transpose of a matrix. So after the transpose of a matrix, then we can talk about two other types of matrices that are under this transpose of a matrix. So we look at transpose, the transpose of a matrix. Transpose of a matrix. Now, when we say transpose of a matrix, the transpose of a matrix simply means that matrix, okay, in which the rows are exchanged for the columns, or the columns are exchanged for the rows. Okay, that is, the rows are exchanged for the columns, which means that the row 1 becomes column 1, row 2 becomes column 2, row 3 becomes column 3, in that order. So when we define a matrix, the transpose of a matrix is a new matrix. Which is composed of the rows and columns of a given matrix, okay, and in which the rows are exchanged for the columns. Okay, so when we transpose a matrix, definitely we are getting a new matrix. So the new matrix is composed of the exchanged rows and columns of the old matrix. For instance, if I write the transpose of matrix A, the transpose of matrix A, we denote this one by, is denoted by A transpose as this. Okay, so if I have matrix A has Aij, that is I rows, J columns, then if we have this, then A transpose will be what? Ji. The number of the rows will be switched for the columns. That's what you have here. So if Aij, then AT transpose will be ATJI. What that means is this. Let's say matrix A is this matrix. Okay? 2, 4, 7, 0, 8, 9. And let's say 3, 2, minus 1. This is matrix A here. When we transpose this matrix A, it simply means we switch the position of the rows for the columns. This row 1 now will become column 1. So here, 2, 4, 7 will be written as a column instead of a row. 0, 8, 9 as a row here, but as the transpose becomes 0, 8, 9 as a column. 3, 2, minus 1 as a row becomes 3, 2, minus 1 as a column. Alright? So in this case here, the rows of A have been exchanged with the columns to form a new matrix. Okay? Now, if matrix P is the matrix 0, 1, 2, 4, minus 3, 0, 4, 4, 8, then the transpose of matrix P will become, okay, we switch this row for the column. So this first row now becomes first column. So we have 0, 1, 2, 4. The second row here becomes the second column. So minus 3, 0, 4, and 8. Now, let's look at the dimensions of these two matrices. Matrix P is the matrix having two rows, 1, 2, 3, 4, 4 columns. The transpose of matrix P, okay, is having 4 rows, 1, 2, 3, 4. 4 rows, 2 columns. So if you look at this, 2, 4, 4, 2. So if P is the matrix Pij, then the transpose of matrix P is the matrix Pji. Okay? So when we talk about the transpose of a matrix, we are simply forming a new matrix by exchanging the rows and columns of the old matrix. Okay, so the rows become the columns, or the columns become the rows. Okay, now, if that is clear, based on this transpose of a matrix, we can also talk about two basic types of matrices. Number one, we have what we call the symmetric matrix. Symmetric matrix. So in the last video, I said this, that some other types of matrices will come up, okay? But we may not discuss them until we have discussed another topic before them. And that's exactly what you are seeing here. So if I have said something about symmetric matrix, you may not have understood that, because I have not really explained transpose of a matrix. Okay, so things have to be done in the right order. So symmetric matrix, therefore, when we say symmetric matrix, this is a matrix. This is a matrix which has the same, or which is equal, let me just put it that way, which is equal or the same as its own transpose. A matrix which is the same as its own transpose is said to be a symmetric matrix. Now, if I have matrix A to be symmetric, if matrix A is symmetric, okay, is symmetric, then A is equal to A transpose. If matrix A is a symmetric matrix, then the matrix A, will be the same as its own transpose. As an example, if I have matrix A being equal to, let's say 1, 3, 5, I have 3, 5, 7, okay, and then I have 5, 7, 6. So I have 5, 7, 6 here. If we transpose this matrix A, if we transpose this, okay, the row 1 here will become column 1. So take row 1, 1, 3, 5. This is 1, 3, 5. Row 2, 3, 5, 7 will become column 2, 3, 5, 7. Row 3 is 5, 7, 6. That becomes column 3, 5, 7, 6. If we check the two matrices, they are the same. Now, at the advanced level, there is what we call a design matrix. A design matrix is basically used with statisticians, okay, under regression analysis. So a design matrix is always a square matrix. Alright, so in this case here, when you transpose the matrix, the transpose of that matrix is still the same thing as the matrix itself. So when you talk about symmetric matrix, is a matrix in which the matrix has the same entries as the transpose. Now, apart from this symmetric matrix, we also have the opposite of symmetric. Opposite of symmetric is anti-symmetric, or some people say anti-symmetric. Okay, anti-symmetric, or you also call it skew symmetric matrix. Now, by being anti-symmetric matrix, what does it mean to be anti-symmetric matrix or skew symmetric matrix? A skew symmetric matrix, one, is a symmetric matrix. That's number one, in which, in this case here, okay, a skew symmetric matrix is a type of matrix, just like what you have here. I'm still going to talk about the transpose. But in this case, the transpose is not just A equal to A transpose. Not exactly the same. In this case here, we are simply saying the matrix is the same as the negative of its own transpose. So this is what we mean here. Anti-symmetric. Anti-symmetric. The North American English will say anti-symmetric. Okay, so anti-symmetric, or you call it the skew symmetric, okay, matrix. Skew symmetric matrix. All right. So when you say anti-symmetric matrix, it's a type of matrix which is equal to the negative of its own transpose. Okay, a matrix which is equal, which is the same or equal to the negative of its own transpose. Okay, so if matrix A, if A is an anti-symmetric matrix, okay, then what that tells you is that A is equal to minus A transpose. Do we have such a matrix? Yes. Okay, now for instance, let's say matrix A is equal to 0, we have 0, 3, minus 2, 0, 3, minus 2, that's a 3, 0, minus 3, 0, 5, minus 3, 0, 5, okay, minus 3, 0, 5, 2, minus 5, 0, 2, minus 5, 0. Let's look at this here. Now, let's take the transpose of matrix A. When we take the transpose of matrix A here, the transpose of this is 0, 3, minus 2. Row 1 here becomes column 1. Row 2 is minus 3, 0, 5. That's column 2 here. This row 2 becomes column 2. Row 3 here becomes column 3, 2, minus 5, 0. Now, if we take the negative of this, negative of this A transpose, this will be 0. Just multiply this 2 by 0. 0, I mean by minus 1. 0, minus times minus here is plus 3. Minus times plus 2 here is minus 2. 3, minus 3 times minus 1 here is minus 3. Of course, this is 0. 5 minus 5 here by minus is 5. Then minus by minus 2 is plus 2. Minus times 5 here, that's minus 1 by 5 is minus 5. And of course, this is 0. Okay, so let's compare this. When we check this A and the negative of transpose of A, 0 minus 3, 2, 0 minus 3, 2, 3, 0 minus 5, 3, 0 minus 5, minus 2, 5, 0, minus 2, 5, and 0. So it simply shows that matrix A is antisymmetric matrix. Okay, so based on transpose of a matrix, we can talk about the two types of matrices, symmetric matrix and the antisymmetric matrix. Okay, so these are two cases here. So please, if this is your first time of coming in contact with this YouTube channel, this is Programmed Mathematics. I am Moses Oluwasegun Alex. I am the tutor on this YouTube channel, and I want to plead with you, please subscribe if you have not done so. Okay, subscribe to this YouTube channel to be able to learn more mathematics topics comprehensively. Okay, and please also share these videos with your friends, relatives, neighbors, everyone around you, so as to reach larger audience. And of course, by doing that, you are helping them, and at the same time helping me in return. Please, I need your thumbs up on the videos, your likes on the videos, your comment as well. If there is anything said here that you feel should have been said better, please put it in the comment section. I am open to suggestions. I'm not going to say you should not raise your suggestion. I welcome every kind of suggestion, but please make sure others also will benefit from it. Okay, so thank you. So in our next video, we shall be looking at some basic elementary operations, basic operations like addition, subtraction, multiplication of matrices. Okay, now before that, now let's just make a simple thing out of this. Okay, let's just make a simple thing out of this. Let's assume that, okay, so I want us to look at this problem. Okay, let's say I have this as a simple example. Okay, we have given that matrix B, okay, matrix B is 4m plus n, okay, minus 5. Then this is x minus m, and this is 7. Given this, and B transpose and B transpose, okay, as given B transpose as 8 minus 5, 8 minus 5, okay, and okay, let me make this one 7 minus n. Okay, so the transpose as and this is 7 and this is 0. Okay, so we have to find the values of m, n, and x. Find the value of m, n, and x. Okay, so if you have to do this, this is also a simple trick. Okay, so we are given matrix B to be 4m plus n minus 5, x minus m, 7 minus n. And of course, let's find the B transpose of this. The transpose of this will mean 4m plus n minus 5, x minus m, 7 minus n. Okay, so we need to find x, m, and n. But don't forget that we have the transpose here to be 8 minus 5, 7, and 0. So this transpose automatically is equal to this one here. 4m plus n, x minus m minus 5, 7 minus n. Okay, so we need to find x, m, and n. X, m, and n. Okay, so let's look at that problem here. So if we look at this now, it's simply saying 8 is this, 7 is this, then 0 is this. Okay, okay, let me change this. Instead of this, let me make this one y. Okay, y, and the 4m plus 5 x minus m, x minus m. Okay, I'm changing this one to y. So let me change that to y. This is y. So we'll find the values of mn, y, and x. So if we transpose this back now, we're going to have, so I'm changing this one to y. Okay, so 4m plus n, x minus y minus 5, 7 minus y. When you have that n, make this y. Okay, let's see that. So this is this now. This is this. Okay, all right. Let me just leave it as n. Whatever the case is, we sort it out. All right. So if we have to solve this now, we are simply having 8 equals 4m plus n. 8 equals 4m plus n. And then for n again, 0 equals 7 minus m. 0 equals 7 minus n. So from here we can find n. So n is simply saying 7 here. Okay, from here find n. N is 7. So if we put 7 for n here, 8 will be equal to 4m plus 7. Bring 7 back here, so 8 minus 7 is equal to 4m. This is 1 equals 4m, and so m equals 1 over 4. Okay, 1 over 4. So we're then to find y. Okay, I think the problem is solved now. So this one here, x minus y is equal to 7. So this is what I was trying to get here. Now this one, I can make it a number. Let me just call it 4. So come back here, change this to 4. Change the y to 4. So let's not create another trouble there. Alright, so we're looking for this and x. Alright, so in this case here, minus 5 minus 5, 0, 7 minus n, then 7 and x minus 4. 7 equals x minus 4, so 7 plus 4 equals x, x equals 11. Now, I know you'll be wondering, why did you not write this out before giving us this? Why is he making correction there in the video? That's mathematics. Okay, now, it's important for you to understand some things. When it comes to understanding what you learn, there are some things you do that will show how much of this you understand. Okay, so if you are a student or you're a teacher watching this, you should always learn to use what you have understood in different ways. I didn't come with a question, I didn't formulate this, okay? Just have to look at it. Let's think of a better way to make use of what we have discussed. And that is the essence of this. That's what we call learning. Okay, if I've crammed this to come here now, what I'm doing here wouldn't be possible. So don't cram, try and understand. It's your understanding that will help you, okay, to be able to solve whatever problem in different form. Alright, so again, we are given matrix B, we are given the transpose of matrix B. Now, if you don't want to do this, you don't want to use the transpose here, I'll give a simple property after this, and then that can be used here. You can decide to take the transpose of this. When you transpose B transpose, it comes back here. All right, so when we transpose this, we have 4m plus n, okay, 4m plus n, where is that? Okay, that's this one here, 4m plus n, 5, minus 5, x minus 4, okay, I said we should change this one to 4, so please make that correction. So x minus 4, 7 minus n, x minus 4, 7 minus n. So this transpose and this one here, they are the same. 8 equals 4n plus n, and then 0 equals 7 minus n. So from there we solve for n, then use the value of n to find the value of 8. Okay, and then having done that, we also calculated the value of x next. 7 and x minus 4, they are the same. So bring back the minus 4 to 7. X equals 11. Alright, so n equals 7, m equals 1 over 4, x equals 11. Now, before I conclude this topic, now look at this. Simple properties of this transpose. Okay? Now, when you have, please note this, just a simple property or just some simple properties. So first one is that the transpose of A, the transpose of the transpose of A is simply the same as matrix A. Okay? What I have here, if I have matrix A now equals 0, 3, minus 3, 4. If I transpose this, I'm going to have 0, 3, minus 3, 4. If I transpose the A transpose again, okay, if I transpose this again, transposing this, I will have 0, minus 3, 3, 4. And that is simply equal to matrix A. Okay, so it's important to take note of that. Then as well, when I have, though we are still going to discuss multiplication, if I have, let's say K times A transpose, okay, K times A transpose, what I have here, if I'm going to multiply this by K times A transpose, automatically this as well could mean the same, is the same as A transpose times K. Okay, where K is a scalar. So when we get to scalar multiplication of matrices, okay, you get to understand this better. Now, by the time we discuss addition and subtraction of matrices also, we'll come back to this property, okay, on addition. So, but for now, this is what you need to take note of. Okay, so that's the end of this class for this topic. So let's see in the next video. So please, if this is your first time of coming in contact with this YouTube channel, this is Programmed Mathematics. I am Moses Oluwasegun Alex, the tutor on this YouTube channel. So please, I implore you to subscribe to my YouTube channel, recommend it to other students, friends, relatives around you. By doing that, you help them to also understand what you have just understood, and we'll be able to reach out to a larger audience. Okay, and also as well, you are helping me also to make a better life for myself. Okay, thank you so much, and we'll see you in the next video.